Hey everyone, let's jump right in. For this explainer, I'll be stepping into the role of your senior cybersecurity consultant, and together we're going to conduct a comprehensive architectural security audit of your online banking platform. We aren't just going to look at a random list of vulnerabilities here. Instead, we're going to map out exactly how your system is built, and more importantly, figure out exactly where the critical lines of defense absolutely must be drawn to protect your customers' most sensitive financial data. Here's our game plan for the audit. We'll start with web evolution and risks, look at architecting online banking systems, and then systematically move layer by layer through the presentation, application, and data tiers before wrapping up with mastering full-stack security. All right, part 1, web evolution and security risks. Let's get into it. Think back to the early days, what we call the static web era. Back then, websites were essentially just digital brochures. They used basic HTML, users mostly just read the content, and since nobody was really submitting sensitive data, security concerns were honestly pretty limited. But an online banking app simply cannot exist in a static web. We are now living squarely in the dynamic web era. Our applications are incredibly interactive, maintaining complex states with server-side scripting and massive databases. Users are logging in, transferring money, interacting in real time. And here's a crazy fun fact for you. Interactive financial applications experience thousands of automated bot attacks every single hour. So while this dynamic functionality is amazing for the user experience, it radically expands our attack surface. Every single time a customer uses your banking app, a massive, complex cycle is triggered. First, their browser has to perform a DNS lookup just to find the server's IP address, establish a connection, and fire off those HTTP or HTTPS requests. Then the server responds with the HTML, CSS, JavaScript, and of course the actual financial data. In a modern distributed cloud environment, this constant, highly dynamic request and response cycle is happening literally thousands of times a second across multiple microservices and third-party APIs. And the catch? Every single one of those interactions is a potential entry point for an attacker. Moving on to Section 2, Architecting Online Banking Systems. Welcome to our digital fortress, the 3-tier web architecture. This is basically the fundamental map we'll be using for our client's online banking audit today. By intentionally separating our system into 3 completely independent layers, the presentation tier, the application tier, and the data tier, we create distinct, isolated zones of trust. This separation is absolutely crucial. It's the blueprint that allows us to apply specific, targeted security controls at exactly the right choke points in the data flow. Let's ground this abstract architecture for a second by walking through a standard user journey. Step 1. Your customer enters their username and password into their browser, which sits at the presentation layer. Step 2. That request travels over to the application layer, basically the brain of the whole operation, which actually checks to see if those credentials are valid. Finally, Step 3. Upon a successful login, the application layer talks to the data layer to securely retrieve the user's account balance, passing it all the way back up to the screen. So the whole system relies on this layered communication. But it brings up a really terrifying question, right? What happens if an attacker just bypasses the presentation layer entirely? What if they trick the browser or manage to send malicious code straight to your application server? To answer that, we really need to conduct our spatial, layer-by-layer security audit, starting from the very outside and working our way in. Section 3. Securing the presentation tier. The presentation tier is your user interface. It's the sleek login pages, the responsive dashboards, the money transfer forms, the stuff your banking customer actually sees and interacts with. It's built using HTML, CSS, and JavaScript. Now, because this tier runs directly out there in the user's web browser, it is completely exposed to the wild, wild west of the open internet. That makes it our absolute first line of defense. But naturally, it's also the most vulnerable to client-side manipulation. Right here at this front gate, our primary threat is cross-site scripting, or XSS, which is a major OWASP Top 10 vulnerability. This happens when an attacker manages to inject malicious scripts right into your web pages. If they pull it off, they can completely hijack a user's session by stealing their login cookies. To defend this tier, developers have to implement incredibly strict input validation. We literally have to sanitize everything the user types in, aggressively stripping out any executable code. Because if we don't, an attacker could drain a user's account just by tricking them into clicking a malicious link. On top of that, we must enforce consistent HTTPS usage, ensuring every piece of communication between the browser and our servers is heavily encrypted. All right, Section 4, Defending the Application Tier. If the presentation tier is the face, well, the application tier is the brain. Built with back-end technologies like Java, Python, PHP, or Node.js, this is where your core business rules actually live and breathe. This layer is the thing deciding whether a user actually has sufficient funds to make a transfer. It processes the payments, and crucially, it acts as the single, heavily guarded bridge to your sensitive databases. Since it holds all the business logic, this tier faces some severe threats straight off the OWASP top turn list. For broken authentication, where attackers try to brute force guest passwords or steal session tokens, we have to deploy multi-factor authentication alongside tightly controlled auto-expiring sessions. Then you have access control failures. The golden rule here is simple. Never, ever trust the browser. Every single privilege check must happen right here, strictly on the server side. Finally, for cross-site request forgery, or CSRF, which is where a user gets tricked into executing an unwanted action behind the scenes, we counter that by requiring strong, entirely unpredictable request verification tokens.
Which brings us to Section 5, protecting the data tier.
Let's assume the worst for a second. An attacker actually makes it past the application checkpoint. We now journey into the most critical part of the entire system. The data tier is the ultimate prize for any cybercriminal. This is where your relational databases, like MySQL or Oracle, or your NoSQL databases, like MongoDB, actually live. Every single sensitive customer record, every password hash, the entire history of financial transactions, it is all stored, retrieved, and managed right here inside the vault.
In the absolute most devastating threat to this vault, injection attacks, specifically SQL injection. This nightmare scenario happens when an attacker sneaks raw database commands through your application layer to trick the database into dumping all its records, or worse, just deleting your tables entirely. To stop this dead in its tracks, our developers must use prepared statements. These essentially strip the execution power away from any user input before it touches the database. Furthermore, we absolutely must rely on robust database encryption. That way, even if the data is somehow stolen, it's completely unreadable gibberish, backed up by strict access controls and relentless secure offline backups.
And finally, Section 6, mastering full-stack security. The true magic of the three-tier architecture lies in its defense in depth. Look, yes, it definitely introduces some engineering complexity, but the operational benefits are just massive. Most importantly, it completely hides the database from direct user access. Because the layers are separate, we can scale them up independently during massive traffic spikes. We can contain our maintenance, so a simple UI update doesn't accidentally break our core payment logic. And we can securely reuse our application layer whether a customer is logging in via their laptop browser or their mobile banking app. But listen, a strong architecture is absolutely not a set it and forget it kind of solution. With modern agile development teams constantly releasing new features and our systems wiring into countless third-party cloud APIs, security isn't just a one-time audit we do once a year. It has to be a continuous integrated DevSecOps practice. We have to catch these vulnerabilities early in the development lifecycle, utilizing static code analysis, dynamic testing, and regular aggressive penetration testing. Which brings us to the end of our architectural audit. As you go back and evaluate your own online banking platforms, I want to leave you with this one critical, provocative question. If an attacker breaches your front gate today, is your next layer actually strong enough to stop them tomorrow? Remember, layered architecture isn't just about building efficiently, it's about guaranteeing that a single failure never results in a total system compromise. Thank you so much for joining me for this explainer, and stay secure out there.